Today we'll begin to look at quadratic sequences. So let's go and see what they look like and what you'll need. We are given the following series. There it is. Now let's quickly test what type of series this is. So what do we need to do? We're going to subtract consecutive terms. So 5 minus 2 is a positive 3. 10 minus 5 is a positive 5. 17 minus 10 is a positive 7. And 26 minus 17 is a positive 9. Now when we look at these answers, we can clearly see that they are not exactly the same number. So this is not a first constant difference. And when we don't have a first constant difference, this is not an arithmetic series. So we cannot use any of the formula or information that we know about arithmetic series. So what do we do next? Well, we are simply going to subtract these consecutive answers one more time. So 5 minus 3 is a positive 2. 7 minus 5 is a positive 2. 9 minus 7 is a positive 2. And look at this. Now that we did it the second time, we see that we have exactly the same answer. This is now called a second constant difference. And when we have a second constant difference, this is not an arithmetic series, it is called a quadratic series. So let's go and see what we can do when we have a quadratic series. Now that we know that we are busy with a quadratic series, we need to know what the general formula looks like. Now here it is. So the term in the nth position is equal to an squared plus bn plus c. Now to solve for the general formula, we need to know what is the value of a, which is the coefficient of n squared. We also need to know the value of b, which is the coefficient of the n, and we need to work out the value of c, which is the constant in this formula. Now here are three very important things for you to remember so that we can work out a, b and c. The first thing that you have to remember is that 2a is equal to the second constant difference. Okay, and then you have to remember 3a plus b is equal to term 2 minus term 1. And the last thing that you have to remember is that a plus b plus c is equal to term 1. Now let's make use of exactly the same example as in the warm-up to show you what these three formula mean. So we take this 2a and we equate it to the second constant difference. Now the second constant difference here is a 2, so we say 2a is equal to 2 and we can solve for a, right? Then the next thing that we do is we take the 3a plus b, which is equal to term 2 minus term 1, and then we equate the 3a plus b to this positive 3, because this positive 3 is the answer of term 2 minus term 1, right? And since we know what a is, we can now just substitute the a and solve for b. The last thing is that a plus b plus c is equal to term 1. So we say that a plus b plus c is equal to this 2, and this 2 is term 1. Now that we know what a and b is, well, we can simply work out c. We're not going to work out the a, b, and c in this lesson today. I just want you to remember what a quadratic series is, and I need you to remember these three different formula because they are very important for us to be able to calculate the general formula, which we will do next time. See you again. Bye.